Let's do a demonstration now where we take a look at OSPF in this broadcast network. The network that I have set up here is relatively simple. I have router A, B, and C. I have loopback addresses set on each one of the routers. We'll take a look at what the router ID is of each router, and then take a look at which router is our designated router, backup designated router, and DR other. And then we'll break one of the routers and have it refigure out which one is the DR and BDR. So now I'm connected to my workstation, and what I've done here is I have those three routers configured to be connected to a layer 2 switch. I have all of the IP addresses configured, including the loopback interfaces, but I have not yet turned on OSPF. Additionally, the three ports on my layer 2 switch are currently in the shutdown state, and I did that so we can bring up OSPF all at the same exact time, so we can see how OSPF will elect a designated router and backup designated router when all the routers come online at the same time. And then we'll play around and see what happens when OSPF loses its designated router. So I'm going to open up PuTTY and connect to router A. On router A, we can do the command show IP interface brief, and that'll show my IP addresses that are currently configured. Right now you can see F00 does have the correct IP address, but the protocol is down. So I have issued the no shutdown command here, but since my switch port is down, my interface cannot come up. Additionally, I've configured loopback 0 here of 192.168.10.1. So if I go now into my config mode and I issue the command router OSPF 10, and I say network 10.0.0.0 with a 24-bit mask, we're going to advertise that in area 0. Remember, when we're working with OSPF, we always have to have an area 0. The interfaces on all three routers in this case are all going to be in area 0. Once I do that, if I issue the command show IP protocols, it is going to show me what OSPF has chosen for its router ID. So right here, it's chosen the IP address on our loopback interface of 192.168.10.1. OSPF is now enabled on router A. Let's go to router B and do the same thing. So move into config mode. I'm going to do a show IP interface brief. Here we can see that I have F00 configured with 10.0.0.2, and again, that protocol is down because the switch port on the other end of that connection is currently down. We'll turn on OSPF, router OSPF 10. We'll advertise network 10.0.0.0 again with that 24-bit mask, and that's going to be in area 0. Once again, if I do show IP protocols now, we'll see that my router ID here is 192.168.2.1. So router A was 192.168.10.1, B is 2.1. Right now it looks like router A is going to be elected our designated router. B would be the backup designated router. Let's go over to router C and do the same thing. So I move my rollover cable into router C. We'll log in here. If I do show IP protocols before I configure OSPF, we'll see that there is no information in it. The output is blank. And the reason is that we don't have any routing protocol currently enabled. Once I turn on router OSPF 10 and advertise network 10.0.0.0 with that 24-bit mask in area 0, now when I do my show IP protocols, we can see that it has OSPF turned on, and we have a router ID chosen here of 172.16.45.1. Now router C has the lowest router ID of routers A, B, and C, so router C should become our DR other. So what we should expect to see is router A should be the designated router, B should be our backup designated router, and C should be the DR other. Let's move over to the 2960 switch now, turn on all three of our interfaces, and see what happens. So I've connected my rollover cable to my 2960. We'll go into privilege mode and then config mode. If I do show IP interface brief, we can take a look and see that right now I have F0, 1, 2, and 3 are all administratively down. So let's go into config mode. We'll use the interface range command here to configure F0, 1 through 3 all at the same time, and we'll issue the no shutdown command here. When I issue no shut, since I've configured these interfaces to use spanning tree port fast, they will come online all at about the same exact time. Now that our interfaces are online, let's go back to router A and take a look at OSPF and see if it's been elected as our designated router. If we do show IP protocols, so we got a message there saying that we've built a neighbor relationship now and exchanged routing table information with neighbor 192.168.2.1, which is router B, and 172.1645.1, which is router C. But take a look at my neighbors now, show IP OSPF neighbor. We'll see right now that 192.168.2.1 is a BDR, backup designated router. 172.1645.1, that is our DR other. If I then do show IP OSPF interface, fast Ethernet 00, which is participating in OSPF here, what we'll see here is that this router is our designated router. Okay, so it's saying the designated router ID is 192.168.10.1, which is this router. So we were correct in our prediction, saying that router A is going to be the designated router. If I go over to router B, on router B, if I do a show IP OSPF neighbor, what we'll see here is that I am neighbored up with both router A and router C. Here we'll see that 192.168.10.1, that is our designated router, the DR. 172.1645.1, that is our DR other. If I do show IP OSPF interface F00, which is where OSPF is configured, it's going to tell us here once again where our designated router is, 192.168.10.1. It also shows us our backup designated router, which is this router, which is 192.168.2.1. If I go over to router C, on router C, if I issue the show IP OSPF neighbor, what we should see here is router C is neighbored up with the BDR and the DR.